Hi, I'm going to go ahead and talk about describing quantitative data, which is chapter 3 in our notes. So you can follow along and write in the notes. This video is going to leave out box plots, but I will make a separate video for that. All right, the topics we're going to be looking at are frequency and relative frequency, dot plots, stem plots, histograms, and an acronym we use, CSOCS. All right, first let's talk about frequency and relative frequency and the difference between the two. All right, so if we wanted to see the difference between frequency and relative frequency, frequency represents counts and relative frequency represents percentages. So if we're looking at salaries, we can see that the frequency are the counts. So one person made 29,000, another person made 32,000, and 4 people made 34,000. So we can be given a table with frequency. We can also be given a table with relative frequency. So relative frequency right here would mean 1 out of 12, which is 8.3%. Dot plots, we have seen how to create them. We can create a dot plot representing salaries. And again, remember, you always want to put a title anytime you have a graph. You always want to make sure you number your number line, your x-axis. You want to state what your x-axis represents. And in this case, the frequency, which is our y-axis, you should always look at your y-axis to understand whether you're looking at counts or percentages. So in this case, we are given frequency, that means counts, and we could see it's numbered 0, 1, 2, 3, 4. And so that would be frequency. And if it was percentage, it would be either written as relative frequency or it would have a percentage symbol. So remember to always label and show your x and y axis values. All right, next we're going to talk about stem plots, and I actually made another video showing how to construct a stem plot if you do not know how to make one. So looking at a stem plot, we would first, depending on our data, we would number from least to greatest. So in this case, 29, and our highest value is 185. So we represent numbers from 2 to actually 18. So you can see the 18 is here, and then we would create our leaves. So this would represent 29, 32, 34, 34, and so on. And another important thing is never leave any numbers out. So in this case, it says 185. You should not jump because there are no values between 7 and 17. You should not leave those out. You should display it. That way you can see that there is a gap in the graph. And obviously this represents salary. So somewhere here, we should have a key. And we should also have somewhere indicating that this represents in thousands of dollars. So the main thing here is the stem is on the left and the leaves are on the right. And we have a key that represents the 3-2 represents 32, but it also represents in thousands. So this would represent $32,000. And again, remember to always label your graph, name it, and always write a title. All right, so this is just showing you how you should never leave out numbers, as I stated before. So don't do dot, dot, dot. You should always include all your values. If you leave out stems, you lose a sense of real location of the data. You don't see how much of an outlier the 185,000 salary really is. All right, next we're going to look at histograms. So we are going to look, you can have a histogram that has, again, the counts. You could have a histogram that represents the percentages. That is called a relative frequency. histogram. You can have a frequency histogram. Again, you will always look at your y-axis to determine which one it is. So in this case, this histogram, you would look at the y-axis and it says frequency. So therefore, you would know this represents counts. So looking over here, I wonder if I could draw. This represents 1. There is 1 person here with a salary of between 20 and 30,000. And there's 8 people between a salary of 30 to 40,000. And there's 1 person again between a salary of 40 to 50,000. 1 person between a salary of 60 to 70,000. And here is an outlier where you could see there's somebody with a salary between 180 to 190,000. Now this histogram is different. Look at the y-axis. It shows us a relative frequency. Relative frequency lists percentages. Now the disadvantage of this is you do not know how many data values you have in each bin. So by the way, each histogram we call a bin, and they're always equally in width. So when it is a relative frequency, we do not know exactly how many items are in each bin. We only know the percentage. All right, next we're going to look at how we describe data. If we're ever asked to describe data, we should always describe it in the following way. The first thing is you should always talk about the context. So what does that mean, context? Are we looking at salaries? You should say the salaries are. Or if we're looking at scores, ACT scores, SAT scores, whatever it is we're looking, we should always talk about that first. When we're looking at shape, it's either right or left skewed or symmetric. So you never want to say it's slightly right and slightly symmetric. It's either one. So you either decide if it's right skewed, left skewed, or symmetric. The modes means that your shape could be unimodal or bimodal or multimodal depending on what your graph looks like. Outliers represents any unusual points. And also in this section, you can talk about any gaps in the graph. And then we have the center where we talk about either the mean or the median, or basically generally where the center is. You always want to say the center is approximately at, or the mean is approximately at, or the median if you don't know exactly. Then we have the spread, which is measures of spread are range, IQR, and standard deviation. And we will be examining all of these more closely later on. All right, so let's take a look at an example. Here's a shape that is unimodal. So you could see there's 1 peak, and this has 2 peaks. Now, what kind of data has 2 peaks? Usually when you're comparing, let's say, cereal brands, maybe one type will have more sugar than another. Maybe one brand of cereal is kids cereal, so it has more sugar. And one brand of cereal is more for adults, so there's less sugar. So that could be one example of a bimodal type of distribution. All right, now we have the shape. So right skew is if you can see that if I draw an imaginary curve, most of the data is on the left, but I will have a tail going towards a right. This is symmetric. If I drew an imaginary curve, it is about, if I folded it in the middle, I would have about approximately the same amount on the left and right. Now, usually symmetric data isn't perfectly symmetric, so you want to say that it is approximately symmetric. Now, in this case, it looks like it's perfectly symmetric, but in the real world, data rarely looks this nicely symmetric. Now, left skewed is when the tail is on the left side. In other words, most of your data is on the right and there's values lingering on to the left. That would be left skewed. All right, so if you have to describe the distribution here, what you can do is pause the video and see if you can describe this on your own. So the context, the shape, the outlier, center, and spread. So pause the video and try it. All right, so if we're looking at the context, we're talking about ACT scores. Notice that we have a frequency, so these are the counts. That means 2 people scored between 9 and 12, 3 people scored between 12 and 15, 5 people scored between 15 and 18, 7 people scored between 18 and 21. We have about 9 people who scored between 21 and 24, and so on. So this is a count, frequency. All right, the shape looks to be, it says left skewed. So in other words, what does it mean left skewed? The tail is going towards the left, and you have the majority of the data on the right. Now, unimodal means there's a single peak. So even if you have 2 bars that are the same height, you wouldn't say that is bimodal. Bimodal is if there's like a disbursement between the data. In other words, you could clearly see 2 modes. So this would, if you drew an imaginary curve, you'd have 1 peak here. Now, outliers, there doesn't seem to be any, and later we will talk about how we actually calculate an outlier. The center is somewhere between 24 and 27, so it would be in this bin right here. And then the spread. So the data varies from somewhere between 9 to 12, so somewhere from the first bin to the last bin. That would be your spread. Now, if you actually wanted to calculate the range, you should give the range as a single number, but you can always say the range is between, because in this case we have a histogram, so we don't really know the actual data here unless we were given, because if I'm given a table, I would be able to tell the exact scores between 9 and 12, but I do not have a table of the data, so all I know is the 2 scores are somewhere between 9 and 12. Just like there are 9 scores between 21 and 24, but I have no clue if it is 23, if it is 22, maybe all of them are 22. We don't know that unless we actually see the table. All right, and how do we describe the distribution? Well, here, data was collected on ACT scores of students in my statistics class. The distribution of scores appears to be left skewed and unimodal. There do not appear to be any outliers. The distribution is centered between 24 to 27, and the data varies from somewhere between 9 to 12 to somewhere between 33 to 36. So you are talking about the context, the shape, if there are any outliers, center, or spread. All right, this is an example of a stem plot, and you can either write it vertically or horizontally. And let's look at stem plots that would be symmetric. So symmetric, if you recall, if you can actually flip this stem plot horizontally, you could see that the peak is somewhere in the middle, somewhat in the middle, and if you drew an imaginary curve, it would be somewhat symmetric. The middle one is obviously more right skewed. You could see most of the data is on the left, and if I drew an imaginary curve, again, the tail would go to the right. This would be opposite if I flipped it horizontally. You could see the data goes towards the left. In other words, it's skewed towards the left, and most of it is on the right side. So here it is showing that they have flipped the 3 graphs, sorry. So here they are vertically, and here they are flipped horizontally, so you can see the shape. The advantages of a stem and leaf is you can actually see the values of each of your data. You can see that this represents 30 and 45 and 62, whereas if I have a histogram, I do not know the actual numbers. I just know the ranges of the numbers in the bins. So now that we have completed this, you should do the Desmos practice.